So hi everybody and welcome back. This is a C++ tutorial series for absolute beginners. This is video 175 and in this video we will talk about const again, but this time const in classes. But before we talk about const, let's repeat a little bit because I took 1 week off and I hope you trained and programmed in this week on your own and learned much more. And if so, very nice. If not, and you take a break as well, that's also nice because taking breaks are important. And with that said, let's make a fast repetition what we have. In my last video, I asked you to solve this little exercise, if you remember it, with this foo class. It was this foo class in Stack Overflow, and there was a guy who answered answered a question, and while he was answering, he showed how the this operator works with different function calls with different return types. And the important part was here, as you remember, there was this one situation. So first of all, what happens? First of all, we created here this foo class, right? And then we just called from the created foo object here, which is our variable, then we just called functions, which are in our foo class here. These are the functions. And there was this irritating point. I think the most difficult one was to understand the second one, which is, oh no, not this one here, the second one, which is just where you have a return type of foo, and the function returns a pointer to it. Also this differencing to this foo, and this foo here is just a copy. And why is this a little bit confusing? Because in this example, what he showed us here below, it is here that he just used the foo variable, then he called this get copy, that is this class here, and then he incremented with other words, he called another class after this. And we learned that when you return a differencing this to the object what you have, and right now this object is a copy object, and you can still access again all the functions in it again, and here at the second point it is doing again. So then he calls this increment on the copied object, and then there was this copied object which becomes 2, and the confusing point was here that in the second line he just not used the copied object here. He is just going back to the foo object, which is the original object, and just called there the function, and that's why the value was here 1. And with other words, he just called here all these functions and then throw away the copied object, instead saving them perhaps in another foo object, what you would normally do, right? So normally if you make something like that, if you create a copy and calling functions on this copy, then you would save this copy normally in another foo object, so to use it. And here the case is it is just called, and in the next line it is never used again. With other words, he's just using the first value. I hope you read this more in detail in online books, in good C++ books and so on, and then you understand this much better than me. And yeah, that was a little bit the difficult part. And of course this other 2 pointers and references, this are more or less just pointing to our class. What I mean with that is we create this one time, and when you have a function with a return type foo as a as a pointer here and as a reference here, both are pointing to the class which you are created when you use the foo and call it in this class, of course. All right, and that's why they are changed our values, because there is only one save location, and this is our class, and I hope you understand this as well. So if you understand pointers and references, this should be also clear. And here, this was also a little bit the point which you have to understand. This one is a pointer. That's why we need not the difference operator here. That will not work because this here, the this itself is a pointer. And that's why we need here assign a pointer. And here we assign the differencing value because we need to assign here the L value to a reference. And the L value here is, of course, our class itself, our object of again. I hope that you learned this one, right? That was this a little bit interesting examples, and important was also that you see that we can call, and actually we could call millions of functions as long as you return this. And you can see a very long line that can happen. And we will learn that we can change these big lines to very small lines if this happens too often. With aliasing, I think, something like, I don't know if it's called this, but there is a way you can make it shorter. And we will use that probably in the later videos. So, but before that, we will talk about const in this video. And here is the other class which you should know. This is the house class, namespace house. The house class which I created all time as an example in my other videos. This is my class big house. You can see I have here two variables, just a string and a int. And then you can see I have here only one function. Let's say a normal function, because it is just printing out my house name. And here I have two, what are these? These are two constructors with initialization, and both are not default constructors. And interesting is, what is this constructor? You think about this one fast. You should probably know it because it's just a repetition what I already explained. When you watch it, I give you a hint. What is this one here? Look, this one. When you see something like this, what do you have to think about? All right, I hope you know it. It is a delegate constructor, which means if you call this one with just a parameter as a string, it will call also this constructor. And we learned with delegate constructors that you can't initialize in the constructor which is calling a delegate constructor, like so, initialize any values. You have to initialize the values in the delegated constructor call, which is this one here. I hope you remember this as well. So important is when you see something like this one. So first of all, you see here's the class name. Then you see the class name is used in the body. Then it is a constructor. But if it's a constructor and you see the constructor has again a call, the class name again, then you have to think fast about a delegate call, which means it's just calling another constructor within this class. That's also very important here to note, because now that we talk about const, that will be interesting here too. So let's go to const. Let's go fast to our page. You know, I use the CPP reference com, and we already covered this keyword const with normal variables here. This const type qualifier, we have not read all through here. I hope you read this a little bit more through now, and you will probably understand it more in detail than before where we started. But important is first of all, this const here and volatile. We know this volatile is used for more for information for the compiler, so it is not used that often. You will not see this word volatile man that much. But on the other side, you will see this word const almost all time, especially with classes, because it's very important in classes. And that's why we have to talk this one now a little bit more in classes. And here you should read this again a little bit if you missing some notes. We have not talked about all things what they are talking here. For example, about this mutable things and so anything like that. We will skip some parts still, but here we go to the next word. It says here const qualified member functions. And when you hear member functions, means most time, not all time, but most time classes, because a member function can be also, I think, in general, a member function is a class, but when it's a member function can also be a namespace member function. Who knows? I don't know this exactly how they differentiate namespace member functions and class member functions. So anyway, in our case, we are concentrating us for class member functions. Okay, we are interested in class member function because we are working right now with classes, and we have here other things. This is a static. Oops, why is static here? We wanted to const. Here down the road we have const. All right, here is const, and then you can read this part here. I will not read it because I will jump to the code and make some examples. Important is that the const is not exactly behaving like the const which we learned with variables. They are slightly different, and this difference we have to learn in this video. First of all, let's start very easy. We start to make a normal variable, what we know. How we make a normal variable, for example, const into my telephone number. You know this already, but important is, this is my standard example I made all time, my telephone number, but important is when you stop here, we get what? We get an error. Why we get an error? We already know this. A const must be initialized when we declare it. So that we learned, right? And the reason for that is, what is the reason for that again? Why we have to initialize it directly when we declare it? The reason for that is, it is const. Const means after you declare this variable here, you should and you are not allowed to change this value. This is fixed. That's why it is called const, and that's why it gives us an error if I would just try to declare it without a value. So we need here a value, right? That's very important, because later, because this one is const, you are not allowed to assign it later. That we know, I hope. That was so standard when we learned const. And here one more info, we learned also that we can put, of course, this const here after this one. And we learned if it's at the start or here, it's the same meaning. I hope you know this as well. Const is normally read all time to the left, but the only exception is when it's at start, then it means the right side, right? This one here and the other one is the same. That was also some specific thing which we learned with const, right? So, but okay, here I created now this const variable, which is my telephone number, and this is just an integer, all fine. Let's try to do the same thing here within my class, and my class is in a namespace, but the namespace has this class big house, and you see here are my variable section, and here I said, okay, I want to make them public, which is normally not good to make public variables in general. There is one more info. You should try to avoid make public variables, because normally you want to make them only private. Only if it's needed to be public, you want to make them public. This is a general rule, but in this case, I make it public so that I don't have to access it all the time with a getter or in a special way, because public means you can access it from outside. We learned this as well when I create here our object big house, then I can just access it if it's public. If it's not public, for example, if it's private, then we learned we have to get a getter function or something like that, which is accessing this variable. And this is a little bit too much work right now, but in general you should make this. You should prefer private variables and only make public if you need public access to it. This is so Also very important to note. All right, but in this case, I make a public const. So what I start again, I start this time with const, and then now I write again int, and not my telephone number. Let's say, okay, now I want this house is Coder's house, and I say, okay, Coder's telephone number. And let's see. And before we learned, right, at this point we learned I can't assign here a value, right? Here, I showed you this example here. That's not possible, right? Here I get an error. But look what happens here. Look what happens here. I stop here and make a semicolon, and I don't get an error. Why? Here at this point it gives me no error, but we are not finished. When we scroll a little bit down, here is the constructor, and the constructor gives me an error. So, and this situation, a similar situation we had already, right? It was with references. There was a similar case, right? When we could declare, for example, a reference here on top. Let's do it as well. Let's repeat this one as well with references. So let's write here, this time int reference, and let's call this one coders reference number. Let's call it a reference number. And you can see here it is also no error, and we learned references need to be initialized at the declaration as well. And why is that so with references? Because they need to refer an existing storage place, which means an L value, and that's normally the requirement. But at this point in classes we learned this already. We can declare it here in this way too, and we have the same problem here. We have to declare it in the constructor, because this is the one special thing which you should remember, that you can do this here. But there is one second note. Wait a minute, but you say, but it's pointing out the error here anyway, so what's the problem with this one? The problem with this one is this kind of stuff. You can later have a header file, which means you should consider this one, or perhaps you just see this one and you should know that you have to still initialize them in the constructor. That's very important, because like I said, we will separate soon the header file with the CPP file, which means declaration with definitions, which means more or less we will separate these bodies here, which you can see, and just with the declarations. But the declaration is still here, so this one you will still see in the header file, I think, too. So with that said, important is, so the const, you can make this const here like I showed you. Here you can't make a const without an initialization. Here you can write it at least at this point. The same goes, we learned this also with references. You can do this, but if you have something like that, both must be now initialized in what? In the constructor. Here we learned this big house is the same name as my class, which means it is the constructor. So let's initialize this. So let's make this, and let's write, okay, what was it? What I have to write here? Coder's telephone number. Let's make this one a copy, and I initialize it. You can initialize it with one of these values, but I think you can initialize it with a hard value as well. Let's write it so and test it perhaps. But now you can see it still gives me an error because I have created this reference here. Let's do the reference as well, why not? Let's initialize this reference too. And the reference is the problem is the reference, you can't use a hard-coded value. For example, this one you can't do. You can see the problem is when you read this one, it says, what is the mistake? Here, initial value of reference to non-const must be an L value. And we talked about this L value. L value means all time. You need a fixed storage place that the compiler knows. So The compiler knows this fixed storage place, can use it, and yeah, that's so the easy explanation, right? So not the absolute correct, but it's easy to understand. And yeah, and the other value here, both are R values. What was the difference of R again? The R value means this number here, 45, is created temporarily by the compiler, which means it is not fixed to a special place. It was just created temporarily, which means it will also delete it after the use case. All right, that's also important. But here the const can use it, because in const version you can use this value and it will be fixed later at this const place here. So that's possible, that's not possible. So what do I have to do here with the reference again? All time when you have a reference, you need a L value. In my case, let's use this house param here, which comes with the call. Let's see, I put it here. And now it works, because this house param, whatever this is, it must be a value which is here. We create here at this point a normal variable. This is a normal variable declaration at this point here. And this variable declaration has now a fixed storage. And this fixed storage I can use here as a L value. I want to not confuse you too much with this L value. Let's concentrate us a little bit more on this const here. So important is we are still const. I made this early, just you can see that this reference and this const here need a initialization. But here is something interesting. I have here two constructors, right? Why I have to initialize it only on one constructor? Because what happens if I call it here? So, you know it? It's not difficult, it's very easy. Think about it, why I don't have to initialize it here. And here is a tip. Look this again. All right, that's my tip. And look this one here too, very important with this one. And if you know it, very nice. If not, I show you now an example. Let's create a house. Let's create an object house, and then we see it a little bit better. All right, let's create it. To create a house, how I create again an object, how I create again a variable of a class. We use the class name, but careful, you have all time check where the class name is. For example, this foo, you would create it like so directly. But in my case, this big house is in a namespace called house, so I have to use this house and the resolution operator to get to this point, because it will not work. If I just write, for example, big house, it will not work, because it says, okay, where is this big house? I can't see, the compiler can't see it. Okay, compiler, look in the namespace house. And then I say, okay, there is it. And now it is created. And now I give a big house the name. Let's call this coder's house. And with this, I need to call in constructor. We learned this too. And let's see, the strange part is this one here. Here, I know I have initialized all the values which I wanted. But what happens if I just call this one here, right? Because here I have not initialized this reference and this const number. All right, let's do this here. Let's call this constructor here, which means I just need to provide this string, and the string is just a house name, and this house name is coder's house, so I call it coder. I just call it coder, and it's a string, so I write it in quotation marks coder. That's enough. And let's see if this is working, and let's start this, and we see indeed it is working. No compiler errors at least. So, which means I have not initialized it here, and it is still working with this one. Why? And like I said before, this one is a what? A delegate constructor, and a delegate constructor means if you call this constructor, this will call this constructor also, and this constructor will be performed first, which means if I call this coder's house with my coder here, it is putting this coder here, but it will call this constructor first, which is it will take the 66 and the name which I put here, which was coder. It will take this both and it will call this constructor here, which means I have here the number 66 and coder, and you can see now I'm initializing this both values, which must be initialized when you create a class. That's very important. These values, you have no initialized values when you define a class, which means you have no created an object till now. You have only the class. But if you create a class like if you create an object like here, because here we are creating a variable which is an object, we want to use it, then we have to define this two things, and exactly that we are doing here. And important is this one will execute first, which means all this code which you can see here will first be called. After this is finished, it comes back to this point here and then executes this part here down. So that's why this is working. So don't get irritated by this one. If you have a delegate constructor, you can't anyway initialize it here because it's just not allowed. That's very important. This delegate constructor here is not allowed to initialize values. You can only initialize values in a non-delegate constructor. All right, that's this part here. And let's go one step further. So, okay, I have now a const function. Okay, a const variable. We are talking right now we talked only about the const variables. I think I make here a short break for this video, and in the next video I want to talk about const functions, because there is also much to talk, and I think that would be too long now. And I hope that you understand all parts so far well. And yeah, with that said, if you have any questions and any complaints like all time, write it in the comments. See you in the next video where we talk about the const functions in classes. Bye, good luck, and like all time, never give up.